looking today at section 6.3, and we're going to move from simplifying expressions to solving equations that involve rational expressions, as well as inequalities. So equations and inequalities here in 6.3. When we're working with a rational equation, the first step should be pretty familiar. We want to factor all the denominators. We're pretty used to that. That's been a pretty standard thing whenever we work with our rational expressions. After we've factored the denominators, that actually leads us immediately to being able to do two things. We should be able to list any values that are excluded from the domain, right? Anything that makes the denominator 0. And also find an LCD for all the fractions. Once we have that LCD, we're going to multiply both sides of our equation by it. And that should lead to simplification that will get rid of all of our fractions and an equation that we can simply solve that results. Do make sure when we're done that all of our solutions are in the domain. If not, we would have to throw them out. All right, so let's try this first one. In this case, there's no factoring that I need to do. Everything's already in a simple form as I can get it. So I'm simply going to say my LCD would just be 3 times x minus 5. So I'm going to take 3 times x minus 5 and multiply that on the left. And then 3 times x minus 5 and multiply that by the whole right-hand side. Right? So there's my original equation, both sides multiplied by that LCD. Now, a lot of people say it helps them if they just go ahead and put a 1 underneath there, and that's perfectly fine, kind of helps you keep track of what the numerators and denominators are. And on this side, I'm going to see that these 3's simply divide out. 3 divided by 3 is 1. And so I have x minus 5 multiplied by 2. On the right-hand side, I'm going to have to take this LCD and I'll have to distribute it to both terms, right, since there's a plus sign in there. So when I distribute to the first term, the x minus 5's will divide out, and I'll get 3 times 7. Then that plus sign. And here, nothing really divides out. So I'm just going to say that that's 2 times 3, or 6, times x minus 5. All right, this is what we want, an equation that no longer has any fractions in it. And you should get that if you've multiplied by your common denominator. I need to simplify this equation, and I'm going to start by distributing this 2. So left-hand side becomes 2x minus 10. Right-hand side is 21 plus 6x minus 30. Which is 6x minus 9. And let's see, I'm going to subtract the 6x from both sides and also add the 10 to both sides. So I get negative 4x equals 1. And x would be negative 1/4. By the way, I did forget to do something. Let me go back and do it real quick. Back at the beginning, the only bad point, the point that I have to throw out of the domain, would be x equals 5, because that would make that denominator 0. And in general, I want to do that mostly so I can compare my answer and say, okay, that wasn't one of the points that's excluded, so this is a perfectly good solution. All right, let's try a few more of those. In B, we do have a denominator that can be factored. the one on the right-hand side. So I'm going to do that first. If I just factor an m out, I have m times m minus 5. And let me follow my own rules here and list my domain and my LCD. All right, m can't be 5. M can't be 0. And m can't be 5 again, but I've already got that. And my common denominator is just going to be this, the m times m minus 5, because it already includes the other one. So we're going to go ahead and we're going to multiply both sides of this equation by that LCD. So multiply by m minus 5 on the left side. And also multiply by m times m minus 5 on the right. All right, on the left, because of that addition there, I'm going to have to take this LCD and I'm going to have to distribute it. So 1 times m minus 5 is just m times m minus 5. Plus, when I multiply this fraction, the m minus 5s are going to divide out. And I'm going to get m times the 4, or just 4m. On the right, there's only one thing inside those parentheses, one term, so I can just go ahead and say, yeah, m minus 5 divided by itself, m divided by itself is just all 1. And so I have 1 times 2, or 2. All right, I'm going to simplify that equation a little bit. M squared minus 5m plus 4m equals 2. And a couple things here. That's m squared minus 1m. And since that's quadratic, I'd like to get it equal to 0. So I'm going to subtract the 2 to move it to the left side. And that gives me the 0 that I needed to see. All right, let's see if we can factor that. Trinomial, so I'm thinking sum and product here. And it's just 1m squared. So I know it's m times m. And I'd be looking for a sum of negative 1, product of negative 2. Sounds like positive 1 and negative 2 would do that. So either m plus 1 equals 0, or m minus 2 equals 0, giving me m equals negative 1, and m equals positive 2. Neither of those were excluded from the domain, so in this case I'm going to say this equation has 2 legitimate solutions. All right, a couple more on the next page. Let's see. First of all, this 25 minus x squared. I'm going to kind of look ahead a little bit and think about that. The way it is right now, that would factor as 5 plus x, 5 minus x. I'd really rather have it in the other order, right? As x minus 5 instead. So I'm going to go ahead and say, why don't I just start by multiplying this by negative 1 over negative 1. I know that that basically turns around the subtraction. That'll make that a positive 20. And then I'm going to do the descending order here. That'll be a positive x squared and then a negative 25. I'm a lot happier with that now because when I factor it, it's just going to be those two, right? X plus 5, x minus 5. So let's go ahead and write that down. All right. The domain here, x can't be negative 5 and x can't be positive 5. And the LCD is going to be x plus 5 times x minus 5, which covers that side as well. All right, so let's multiply both sides of the equation by that LCD. Okay, left-hand side, there is a sum here, so I'm going to have to distribute and put this over 1 if you want to. But I have to distribute that to both fractions. In the first fraction, I can divide out the x plus 5s. So I'll get negative 2 times x minus 5. And plus, and in the second fraction, it's the x minus 5s that will divide out. So I'll get 3 times x plus 5. On the right side, it's just one fraction in here, so I can just literally divide those out. Everything divides to 1 here, and so I have 1 times 20, or 20. All right, no more fractions, should be able to solve this equation. So that would be negative 2x plus 10 plus 3x plus 15 equals 20. 1x plus 25 equals 20. So x equals negative 5. Now we didn't do anything wrong in terms of the solving process, but that is an excluded value. It's not in the domain, and it's the only possible solution I got, and yet I have to throw it out. That tells me that this equation actually has no solutions. And that's the main reason that I like to write out the domain ahead of time, is just helps me recognize when that kind of thing happens. All right, what about D? Definitely some factoring I can do here. Thinking sum and product, starting with x times x. Sum negative 6, and product of 9. It's going to be negative 3 and negative 3. In the second fraction, I could factor a 3 out of the denominator. So 3 times x minus 3. And that's equal to x over, looks like we can take out a 2, 2 times x minus 3. right, domain. X definitely can't be 3, and I think that actually covers all of them, right? So just X can't be 3. LCD. I have X minus 3 times X minus 3, or if I want to, I could write that as X minus 3 squared. Here and here, I've already got the X minus 3's covered, but the LCD for the factor of 2 and the factor of 3 would be 6. So I'm going to go with 6 times X minus 3 squared as my LCD. So I'm going to multiply by that on the left. And again, I'm just going to write that as X minus 3 squared. And I'm going to multiply by that same LCD over here on the right. Okay, left side again, there's that plus sign, so I know I'm going to have to distribute this. And in the first fraction, the X minus 3 squareds will divide out. And I'll have just the 6 times the 3. Over here, it's a little bit more complicated, so let's think about this. First of all, I'm going to say 6 divided by 3 is 2. One of the X minus 3's will divide out, but the other one's still going to be there. And then that X minus 2 is still there as well. Get through one more time. 6 divided by 3 gave me the 2. If you want to, you can even think about this as subtracting exponents. 2 minus 1 left that X minus 3 to the first power. And then this X minus 2 from the top, also still there. Equals. On this side, 6 divided by 2 is 3. Same idea with the X minus 3's, right? That's a second power, that's really a first power. You can think, hey, one of them divides out, or you can think of subtracting the exponents. Either way, we're going to get X minus 3 still to the first power, times that X right there. All right, all the fractions are gone, that's a good thing. Let's multiply this stuff out. I have 18 plus 2 times, and I'm just going to go ahead and do my FOIL or my double distributive law in here. It's x squared minus 2x minus 3x plus 6. And on the other side, there's a couple different ways to do this. You could bring the x up here and just distribute them all at the same time. Maybe I'll do that. In fact, I'm going to take that x and just write it there instead. And then that makes it a little easier to see. That's 3x squared minus 9x. All right, all the fractions are gone, which is great, but I still have a ways to go to solve this equation. Let's see, I have 18 plus 2x squared minus 4x minus 6x plus 12 equals 3x squared minus 9x. And I'm just going to combine and write descending order here on the left. I have 2x squared minus 10x plus 30. All right, it is quadratic, meaning I would like to get it equal to 0. And I think I'm going to actually move everything to the right. Notice if I subtract the 2x squared, I'll get a positive 1x squared. And that makes my factoring process a little easier. So let's do it that way. So now I have 0 on the left and x squared plus x minus 30 over there on the right. It's a trinomial, so sum and product again. 1x squared means I do start with x times x. And I'd be looking for a sum of 1, product of negative 30. All right, 6 and 5, 6 positive and 5 negative. We'll do that. So x plus 6, x minus 5. And that says that either x plus 6 equals 0 or x minus 5 equals 0. Giving me two solutions, x equals negative 6 and x equals 5. Both of those are in my domain, right? The only bad value that I had to throw out there was 3. So these are both perfectly good solutions. All right, oops, looks like I got one more here. As always, we want to start by looking for our factored forms. So let's do a bit of factoring here. If I can get my focus to work. There. All right. So on the left, I have x plus 4, and another trinomial, so a sum product deal again. I'm going to start with x times x to get that 1x squared. Sum of 1, product of negative 2, be x plus 2 and x minus 1. Plus x plus 1, and let's see, that's just a difference of squares. X squared is x times x. Negative 4 would be positive 2 times negative 2. Equals, and on the right-hand side, I've got a trinomial again, so sum and product, but I can start with x times x to get the x squared. And then I need a sum of negative 3, product of 2. So I'm thinking negative 1 and negative 2. All right. My domain. X can't be negative 2. X can't be positive 1. Negative 2, but I've already got that. Positive 2, 1, and 2. So it looks like the three numbers that would create zeros in the denominator are negative 2, 1, and 2. Got to throw those out of my domain. LCD. Got the first one, x plus 2 times x minus 1. Second one, x plus 2 is already there, but I need the x minus 2. And x minus 1 is already there, x minus 2 is already there, so nothing new from that last fraction. So that is my common denominator. All right, I got to multiply by that whole LCD. Times this left-hand side. equals, I always got to do the same thing on both sides. So on the other side again, multiplied by the same LCD. All right, put these over 1 if you like. And then we take this and we distribute it to both fractions, both terms inside those brackets. So let's see. The x plus 2 and the x minus 1, those will divide out. And I'll get x minus 2 times x plus 4. Plus the x plus 2 and the x minus 2. Those are going to divide out. And so I'm going to get x minus 1 times x plus 1. And finally over here, equals on the right-hand side, the x minus 1 and the x minus 2 will both divide out. I have x plus 2 times x minus 3. All right, all my fractions are gone, so that's a good thing. I do have a bit of algebra to do, though, to figure out what this equation is going to do. I got 1, 2, 3 separate multiplication processes to go through here, so let's get started. First pair, when I multiply, is going to give me x squared plus 4x minus 2x minus 8. Second pair, so plus x squared plus 1x minus 1x minus 1. And then the equal sign. And then x squared minus 3x plus 2x minus 6. Whew, all right, simplify everything we can. On the left side, I have 2x squareds. 1x and negative 1x just makes 0, so as far as the x's, I have a positive 2x here. And then it looks like a negative 9. And that equals x squared minus x minus 6. All right, definitely quadratic, meaning we want to get that equal to 0. So let's see, I'd like a positive 1x squared, so I'm going to subtract x squared from both sides. And I'm just going to keep moving things over to get the 0 on the right this time. So I have x squared plus 3x minus 3 equal to 0. All right. Trinomial, so 3 terms, sum and product again. But this time, if you think about that one, I don't think it's going to work. Sum of 3 and a product of negative 3. Can't do that. So it doesn't factor. If it doesn't factor, we can fall back, since it's quadratic, on the quadratic formula. So let's see if I can sneak that in here. Minus b would be negative 3. Plus or minus the square root of 3 squared minus 4 times the a, which is 1, times the c, which is negative 3, over 2a, or 2 times 1. Let's see, what have I got under that radical? That's a 9 minus a negative would be plus 12. 9 plus 12 is 21. And I believe that's actually done. There's no perfect square that goes evenly into 21, so I can't simplify the radical at all. It's not imaginary. Those are real numbers, right? They're just real numbers that don't come out perfectly evenly like an integer or something. Certainly neither one of them is any of those excluded values. So I'm going to say, there we go. We got two solutions to this rational equation. All right, let's move on to talk about inequalities next. And what you have here is a graph of the function x minus 1 over x plus 2. And we're supposed to this time just use the graph to solve the inequality that says that it's greater than or equal to 0. I would like to go ahead and put the asymptote on this graph. Notice if you think about the domain, x can't be negative 2. And if you look at x equal negative 2, that certainly seems to make a very reasonable vertical asymptote on this graph. All right, I want to know where the fraction is greater than or equal to 0. And as I look at that, I can definitely see that this whole section over here is all bigger than 0. Oops. So that section of the graph is going to be a true part of the solution. In this section, it's below 0, so I don't want that part. But then starting here at 1, once again, this is greater than or equal to 0. So the x values for the sections of my graph that satisfied the inequality, greater than or equal to 0, would be from negative infinity to negative 2, and then from 1 to infinity. Now I deliberately left off the parentheses and brackets here because I want us to think about this. Usually, well always I guess I should say, there's parentheses on the infinities. That's the easy part. And normally, with a greater than or equal to, you'd put brackets, right? But in this case, notice I can't put a bracket at the negative 2 because negative 2 is not in the domain, right? This graph never actually touches that asymptote at x equal negative 2. So I'm forced to put a parenthesis there. 1, however, really was on the graph, so I can put a bracket in there. Okay? So you'll have to think a little bit more carefully about parentheses versus brackets when you're solving these rational inequalities. All right, we're going to go to an algebraic method of solving them next. And I want you to think about the method that we've used in the past for solving inequalities. Typically, we solve the related equation, then we put those values on a number line and we test our intervals. We're going to do something very similar here. In fact, we are going to solve the related equation to get some values. But I also want you to notice that in addition to the actual 0 here at 1, this graph also changed from positive to negative at the asymptote. The negative 2, that was the value excluded from the domain. So we're going to have one extra thing to think about when we solve these inequalities by hand. First of all, list x values excluded from domain. Secondly, solve the related equation. And then thirdly, we have to include not just the solutions to the related equation, but also the x values that were excluded and put all those points on our number line. That should create a certain number of intervals. We test 1 point per interval. To determine whether our inequality is true or false. Right, we've seen that a number of times this semester, so that should be really familiar. And then finally, the solution is just where it's true. All right, let's give this a try. Again, the only real new piece is including those x values that were excluded from the domain. All right, as I look at A, first thing I'm going to do is say, you know what, and actually I probably should have put this even as a step 0. Get 0 on one side. We've seen that so many times I forget to write it down now. So let's get our 0 here. We would have x minus 4 over 2x plus 4 minus 1 is greater than or equal to 0. All right. If x is negative 2, that would put a 0 in the denominator. So I'm going to say x cannot be negative 2. That takes care of my step that says list all those x values that are excluded. All right, I'm now ready to look at my related equation, which is just this with an equal sign. And to solve that equation, there really is only one denominator. So I'm just going to multiply both sides by that denominator. 2x plus 4. All right, and again, if you like that over 1, you can certainly do that. On this side, I have to distribute. 2x plus 4 divided by 2x plus 4 is just 1. So really, I have 1 times that x minus 4. Minus. When I distribute the 2x plus 4 over here, I'll get that negative 1 times 2x plus 4. No denominator here, so nothing divides out. And goodness, I said I was going to write it as a related equation, and I kept writing it with a greater than sign. Sorry about that. Let me fix that. This is the equation now. So I wanted that to be equal. On the right-hand side, anything times 0 is still 0. By the way, there's actually a really important point why it's important that this is an equation and not an inequality. I don't know what the value of 2x plus 4 is. So I don't know if I'm multiplying by a positive value or a negative value. Meaning if I had an inequality, I don't know whether to switch the inequality sign or not. That's why it's really important to go to the related equation first. All right, let's simplify this thing. X minus 4 minus 2x minus 4 equals 0. Would be negative x minus 8 equals 0, or negative 8 equals x. So I'm going to take those two values, the negative 2 and the negative 8, and those are the ones I'm going to use on my number line to create my intervals. All right, so let's see here. -8 and -2. Remember, this is the inequality that I'm testing to see if it's true or false. And you might want to put that into either Desmos or a calculator to make it a little easier. I'll do that in a moment. Let's see, what are we testing? Let's check -9, -5, and 0 as my test values. So I'm going to use the calculator just so I don't have to keep switching screens, but works in Desmos, of course, as well. My function is x minus 4 over 2x plus 4. Minus 1. And my goal is to have that be greater than or equal to 0. If I go to my table and I put -9 as my first test value, I get about -0.07. Wanted it to be greater than or equal to 0, but of course that's false. Let's plug in -5 next. Gave me 0.5, and that is greater than or equal to 0. So the middle section is true. And then I plug in 0 for the last one. Gives me -2. Wanted it to be greater than or equal to 0, but of course that's not. So that one's going to be false. So the only section that was true this time is from -8 to -2. All right, let's think about parentheses and brackets. Greater than or equal to means I'd like to use brackets if I can. The -2, however, is excluded, so I have to put a parenthesis on that side, but I can put the bracket on the side with the -8. All right, we'll try a couple more inequalities here. In B, we already have the 0 on one side. And so I'm just going to go ahead and say, since there's just one fraction, there's really not a whole lot of point in bothering factoring. You can if you want to, but I don't really need to. So let's just start by writing the domain. X can't be 2 and x can't be -2, right? Those are the two solutions to x squared minus 4 equals 0. And then I'm going to write my related equation. Make that an equals 0. The LCD is the only denominator. So I'm actually just going to do it right in here this time. Let's multiply the left side by x squared minus 4. And let's multiply the right side by x squared minus 4. On the left, those divide out and give me just a 1. And 1 times all of that is itself. That's just going to be equal to 0. 0 times anything is 0. All right, 3 terms. And so I'm thinking sum and product. 1x squared is x times x. And let's see, I'd be looking for a sum of 10 and a product of 25. So 5 and 5 which says x plus 5 equals 0 or x plus 5 equals 0. And of course that gives me a solution of x equals negative 5. It happens to occur twice, or we could just say multiplicity 2, but either way, it doesn't really matter. I'm going to put that number on my number line. So let's go to our test. I had the 2 and the negative 2, and I have the negative 5, and all 3 of those values go on my number line. So this time I've got 4 sections that I have to test. And it's just way back to my original inequality that I'm going to test here because I already had the 0. So I'm going to pick some test points and we'll figure out which ones actually give us a value greater than 0. So I'm going to go with negative 6, negative 3, 0, and positive 3. Let's see, my original function x squared plus 10x plus 25 over x squared minus 4. And my first test point is negative 6. Gives me 0.03. I wanted it to be greater than 0, and it is, so that's true. All right, what about negative 3? Gives me 0.8. Again, I wanted it to be greater than 0, still true. All right, let's look at 0. 0 gives me negative 6.25. That is certainly not greater than 0, so we'll have false here. And then finally 3 gives me 12.8. And that is greater than or is equal to 0, so true again. All right, so let's think about where this is true. 3 of my intervals turned out true. And I'd like to ask a question here. Do I really need to write this as 3 separate intervals, excuse me? Or could I just go all the way from negative infinity to negative 2? I actually have to write them separately, and here's the reason. This was just greater than 0, not greater than or equal to 0, and the negative 5 would make it equal to 0. So for that reason, I have to go from negative infinity to negative 5 with a parenthesis, and then from negative 5 to negative 2 also with a parenthesis, and then from 2 to infinity. If I can just make a quick note on this one, if I'd had almost the same problem, but it was greater than or equal to 0, now I could have gone all the way from negative infinity to negative 2. Because it's okay to have the negative 5 included, the negative 5 made it equal to 0, and I'm now allowing that. Notice the negative 2 is still excluded, so that's still a parenthesis. And the positive 2 is also still excluded, so that's still a parenthesis as well. Okay. So some of the techniques here are familiar, but probably the newest thing is simply a matter of keeping track of those parentheses and brackets. All right, I've got one more for us here. And this one, I'm really grateful that I've already got 0 on one side because it's going to make it a lot easier. We saw on this last one, right, that when one side is 0, clearing the fractions is relatively simple because the 0 side just stays 0. I'll be taking advantage of that again here in part C. All right. First of all, what are my excluded values? Well, -1 would make that denominator 0, and it's the only real number that makes it 0, so -1 is excluded. I'm then going to say my related equation, rather. Looks pretty much the same. Just make it equal to 0 now. And then I'll multiply both sides by the common denominator, which is the only denominator, x cubed plus 1. All right, that means those can divide out, and the left-hand side is 2 minus x to the 3rd power times 3x minus 2, and that just equals 0. So 2 minus x cubed equals 0, or 3x minus 2 equals 0. This just says 2 minus x equals 0, so x would be 2. And this would be 3x equals 2, so x would be 2/3. So there are my 3 values for my number line. The excluded value, -1, and then the 2 solutions that make it equal to 0, the 2 and the 2/3. So let's test. -1, 2/3, and 2. I am testing my original inequality. And I'll pick a few test values. Let's go with -2, 0, 1, and 3. All right, so first I'm going to put in my function. And my first test value is -2, which gives me 73.1. I wanted that to be less than 0, which is clearly false. My next test value, 0, gives me -16, and that is less than 0. True there. 1 gives me 0.5. That is not less than 0, so I'm false again. And 3 gives me -0.25. That is less than 0, so that one's true. And let's see, I don't have to worry about brackets at all. This is just less than 0, so everything's parentheses. From -1 until 2/3, and then from 2 to infinity. All right, I'm going to pause there and go ahead and we'll do the next page in the next video. But that brings us to the end of all of our by hand work on this material.